Somewhere in northern Chile, in the early hours of July 1st, 2025, someone was going through the night's images. Routine work. Most nights are. This one wasn't. There was a faint object moving across the frame, and it was moving fast enough that it immediately stood out from everything else in that night's data. So they did what you do when a number doesn't make sense. They checked it again, and then they traced it backward, trying to figure out where it had come from. It hadn't come from anywhere in our solar system. It hadn't come from anywhere near it. This thing had been drifting through interstellar space for billions of years before it ever crossed paths with our sun, which raises a question astronomers have only been able to ask 3 times in all of human history. What actually happens when something from outside our solar system shows up here? This is the story of the 3 times we found out, and why the answer keeps getting stranger. This is Kestrel. Let's go back to the beginning. October 19th, 2017. A survey team in Hawaii running a program called Pan-STARRS is doing exactly what it does every clear night, scanning the sky for anything that moves, and something catches their attention. Nobody knows yet what they're looking at, just that it's moving in a way that doesn't fit anything in their catalog. Within days, it's confirmed. This is it. The first object ever detected coming from outside our solar system. They name it Oumuamua, Hawaiian for a messenger from afar arriving first. Here's the thing. Every comet or asteroid anyone had ever tracked before looked more or less the way you'd expect. Roundish, chunky, tumbling through space in a predictable way. This one didn't. Based on how its brightness kept changing as it tumbled, researchers worked out it had to be at least 5 to 10 times longer than it was wide. Nothing on record came close to that shape. A few asteroids are elongated, just nowhere near this extreme, and it kept getting stranger. Comets usually drag a tail behind them, a glowing trail of gas and dust as their ice starts to evaporate near the sun. This object had none of that. No tail, no visible haze around it, which made it look more like a bare rock than a comet. Except bare rocks don't do what this one did next. As it left our solar system, it sped up. Only slightly, but in a way, gravity alone couldn't account for. Something was pushing it. For something with no visible tail, no visible gas, nothing venting off its surface that anyone could see, that acceleration didn't add up. One Harvard astrophysicist, Avi Loeb, floated an idea that ended up everywhere. What if this thing wasn't natural at all? What if it was built, not born? A solar sail, a probe, something artificial drifting through the void? Most of the field pushed back hard, and years later, a more grounded explanation emerged. The object may have been venting hydrogen, trapped inside its ice since it first formed, billions of years ago, too faint for any telescope to catch directly. That alone could explain the odd acceleration. It's a satisfying answer. There's just one catch. This thing was only visible for 11 days. By the time anyone fully grasped how strange it was already gone, moving too fast, too far for anything on Earth to keep up. 11 days. That's all we got with our first interstellar visitor. And to this day, nobody can say with total certainty what it actually was. 2 years later, an amateur astronomer named Gennady Borisov was doing something a lot less institutional than Pan-STARRS, scanning the sky with a telescope he'd built himself from his own backyard in Crimea. No observatory, no research team, just one person, a homemade telescope, and a lot of patient nights. On August 30th, 2019, that patience paid off. He found the second one. This time, there was more warning. As the object, now called 2I/Borisov, kept approaching the sun, everyone got a much better look at it. Which brings us back to that question from the start. What happens when one of these things shows up? This time, the answer was almost disappointingly simple. It behaved exactly like a comet should. A visible coma, a glowing haze of gas, and a tail, just like the comets already familiar to anyone who's ever looked up. No weird shape, no unexplained acceleration, just a normal comet. One that happened to come from another star system entirely, which sounds almost anticlimactic. But here's why that actually matters. Borisov gave astronomers their first real look at what a normal interstellar object might chemically be made of, and the answer was strange in its own quiet way. Borisov had an unusually high amount of carbon monoxide, more than any comet ever measured at that distance from the sun. It also turned out to be one of the most pristine comets ever observed, meaning its ice was barely altered since it formed, billions of years ago, around a star we'll never identify. So now we had two data points, one wildly strange, one strangely normal. And for almost 6 years, that's all we had, until 2025. July 1st, 2025. The same night we opened with a survey program in Chile called ATLAS, built to watch for anything dangerous heading toward Earth, picks up a faint, fast-moving object. Within days, it's confirmed. The third interstellar object on record. They name it 3I/Atlas, and almost immediately, it starts breaking records. It was clocked moving at over 220,000 kilometers per hour when it was found, and it kept speeding up as it fell toward the sun. It's noticeably bigger than the first two, a nucleus possibly over a kilometer wide, and when the James Webb Space Telescope got a look at its chemistry, it found something no comet native to our solar system has ever shown, an unusually high ratio of carbon dioxide to water. But the strangest part came from something else entirely, tracing this object's path backward all the way through the galaxy. 3I Atlas may be nearly 12 billion years old. For context, our sun is about 4.6 billion years old. This thing had already been drifting through the galaxy for more than twice that long before our solar system was even a thought. The star it came from may not exist anymore. It may have burned out, or collapsed, or scattered into dust long before Earth ever formed. This wasn't the first time the name Avi Loeb came up in this story. He was the same Harvard astrophysicist behind the Oumuamua probe theory back in 2017, and this time he came back swinging harder. 22 separate anomalies, he argued, that a standard ancient comet shouldn't have. The claim didn't stay in academic circles for long. It spread fast, across news outlets, YouTube, social media, turning a chemistry debate among a small group of specialists into a public argument about whether we just found alien technology. To be clear, the overwhelming scientific consensus, backed by Hubble, Webb, and observatories around the world, is that 3I/Atlas is a natural comet, an extremely old, extremely unusual one, but a comet. No sign of artificial technology has been found, but the debate that erupted around it in 2025 was real. And it says something interesting, even now with far better telescopes than we had in 2017, distinguishing extremely strange from artificial is still genuinely hard to do with total certainty. As of this year, 3I/Atlas has already made its closest pass by the sun, swung by Jupiter, and is now fading, heading back out into interstellar space, the same way it came. We'll likely never get this close to it again. So, what actually happens when something from outside our solar system shows up here? 3 times and 3 completely different answers. One so strangely shaped it briefly had a serious field of researchers debating alien technology. One so ordinary it showed us exactly what a normal interstellar visitor looks like. And one so ancient it may have been drifting through the galaxy since before our own sun existed. Here's the part most people don't know. For decades, finding even one of these was considered incredibly rare, a once-in-a-generation event. That's about to change. In June of 2026, the Vera Rubin Observatory in Chile officially began its 10-year survey of the entire sky. Scientists working with Rubin estimate it could detect a new interstellar object every few months, not every few years, which means the next interstellar visitor isn't a matter of if, it's a matter of when, and we have no idea if it'll be as gentle as the last 3.